Welcome back to the second part about binary space partitions in Doom 3. This time we look how we can utilize them for our advantage. It covers how the portal frustum culling hides unwanted objects from the renderer backend, which is essential for a good performance. It also shows how entities can interact with the BSP tree, like doors, and how the BSP influences the new RB Doom 3 BFG specific light grid for indirect lighting. In order to show how the portal frustum culling works, I want to have a map that is a bit more complex than this one. So we duplicate this floor. And then we move it over here. Then we duplicate just everything. Okay. And we don't need this part here. And then we will cut through the wall by the CG operation subtract. Okay. Here again. Okay, texturing is not perfect, but that doesn't really matter here. This is just for illustration purposes. And then I want to remove this portal so it doesn't have any effect any longer. All right. Now let's have a look how this works out in the engine. I just realized that I forgot to remove the second array portal, so I had to recompile the map. And I want to show you a few console commands and variables that you can change in order to see how the BSP works within the engine. And for this, I want to remind you that there is in Doom Dev base a DevTools CFG, where you can enter or execute any commands, and you can bind several keys to certain commands, which is really helpful during development of anything, and also for analyzing the engine. And in this case, we are interested in r_show tris. We don't need the value 3. We are interested in r_show lightgrid, and we don't need post-processing. We want show portals here. Okay, and we can execute this config in the engine with exec devtools cfg. And if I press F2 now, we see the wireframe mode. If we press F2 again, which is equivalent to r_show tris 2, the wireframe mode, but this time it ignores the dev buffer testing. So we actually see what's going through the renderer backend. All the polygons, all the meshes, objects that are actually rendered can be seen this way. So in this case, it's obvious that this is not optimal because we don't want to render any unseen, unwanted objects from the other rooms. It would be just logical that there might be some culling issues here with the objects hidden right behind this corner, but those other rooms should be invisible completely. Yeah. Okay, then skip it and we press F6. And with F6 we have the light grid, which is only the light grid of the current area, and it's also limited in the range. If we press F6 again, we have another mode which shows the light grid of all areas. And there's also N, and the N key is also bound to no clip. So if we press N, we can fly around, we can leave the map and see how the light grid bounding is. The size of the light grid is exactly the size of area 0. That's just one area because we don't have any area portals in the map. Yeah. Okay, so let's go back to Trench Boom and add some area portals. As a rule of thumb, there should be one area portal between each room and floor. So we have each room separated from each other. So just put this back. Then we can duplicate it, rotate with Alt, the cursor keys. Okay, we select both, duplicate, and we move them to the other two rooms. Okay. Also, we don't need the second info pair start. Also, it's the first one. Interesting. We just remove this one. And then we also need two wisp portals for this floor. I'm going to do this in a top-down view. You can also rotate here with Alt, cursor arrows. And then we move in. All right. Every room is or should be disconnected from each other by the portal. So you can still go through each room. We also don't need this one here as an obstacle. And okay, let's see how this works out in the engine. When we press F2 again, we can immediately see that the portal culling works. Yeah. So just make around here. Okay, the next room is visible. This is also very interesting here, that objects are popping up, but they're really culled immediately as the boundary box of the object is hidden. Yeah, right the corner. So that's a very good culling technique, especially for indoor games. And if you remember, we changed the config file for the F8 key toggle air show portals. So we can also enable this, and then we can see what kind of portals we have. So it shows the portal boundaries, and if it's open, then it's green, or if it's visible, and if it's not visible through the other portal, it's red. So you can see whether it's enabled or not. And as you can see, when it's enabled, when it turns green, the other portal at the end of the floor is also visible immediately. This is basically how the stuff works. So we don't have the room visible, and now, bang, it's there. And if we cross this border, the other room behind is also visible. So this technique is actually a bit more precise and better than what we have in Quake 1 or Quake 3, because that was a very rough estimation of how the visibility system worked and was visible or not. But this is very precise. We have really great control over it. Okay, just another few words how the portal frustum camera clipping works. And why it's so effective. So when we are running around with the player, imagine this is the player position for the moment, and we have some kind of 80-90 degree camera view or field of view. We can imagine that this shapes up a camera pyramid, which is also called a camera frustum, and this is just a top-down view of it. However, there's a left side, right side, bottom, and upper corner. And you can imagine that there's an infinite far away plane for the clipping, and there's one plane right behind the camera. And every object outside of these boundaries will be rejected and not rendered anymore. And if you're running around with the player, the first thing the render does is, where are we located with the camera? So we are asking the BSP tree in which area we are. So this is probably area 0. Then we have area 1, area 2, area 3, and it will ask this area, do we have any portals left? So first of all, it collects the meshes of the current area and also collects the entities or the meshes of the entities of the current area, and that is what it knows what needs to be rendered. Yeah, and everything outside of this camera frustum, of the regular camera frustum, will be rejected. And then we continue with this thing. So if it has any area portal, it will reduce this camera frustum to this portal, to these portal boundaries. Okay. So this would be like this. So okay, this isn't a big impact. And then we would check if is anything visible within these new frustum. Okay. And then it goes even further. Restrict the next lookup with these boundaries here, with these two lines. So we're looking through this portal, or the last portal that is visible to us, because this portal isn't isn't visible through this portal. And we can also see, okay, that is your new camera frustum. So I just remove the other ones. This is your new camera frustum, and anything outside of this camera frustum will be rejected. And that is why it's so fast. Okay, as a quick reminder, this is how the light map was looking when we had no area portals in the BSP. And this is exactly how the light grid would look like with Quake 3, because there was only one light grid that was expanding over the entire visible map. Well, this is not Quake 3. This is a new implementation here with the light grid. And we have a look at this now with those area portals. So we go outside the map and we press F6 2 times. We can see there's not a single light grid. There's a light grid for each BSP area. And that is how we can control the light grid. And imagine you have to render and calculate all the points in between those areas. That would be a lot more expensive than just those tight new smaller light grids. And this is also the main reason I developed the system this way, because it wouldn't have been possible to calculate the light grid for the original Doom 3 maps. If we look at those, okay, this is the first Delta map, and we enable the light grid so we can see it. And if we move out of the starting location, this map is already huge, and the hell maps are even way, way bigger. So this area portal system, or these BSP areas, are really handy to automate the entire process. And if you look at these light grids, there's a very similar technique developed by NVIDIA, which is called dynamic diffuse global illumination. And there were some prototypes in Unreal 4 as a plugin for the engine. And imagine you have to set all those boxes for each room afterwards after creating the map manually. It is a lot of work. It's just a lot of work. And the BSP this way automates the entire process. You don't have to do anything as an artist. Just set a few portals and you're done. It's really awesome, actually. And if we hide those and enable those reflection cubes, this is also what we have as an advantage. And enable the portal in between those areas. So these are the reflection portals that are responsible for the specular reflections in those maps. And I could put as an environment probe into the center of each BSP area automatically without the need to place it manually. I also added a few with just a shortcut by running through the map and placing those environment probes, similar like you did this stuff when people developed the early bots for the Half-Life engine, or the Half-Life game, the first one. This is something you can do. This is then a safe and smart way. But if you have to do this manually as an environment artist in the map editor, this just sucks. It really sucks. And you want to avoid as much work as possible to get something done. So even if the binary space partition seems to be an outdated concept for many people, this is actually quite handy, even today. I'm glad that you made it this far in this video. So the next step I want to show you is that entities can interact with the BSP areas or the BSP tree, which is very cool. So as an example, we make a door. We duplicate this portal brush, extrude it, or just move it a bit. Then we are looking for a door texture. So this is basically textures based door. Can group everything. Okay, and that doesn't look bad. We select the face, align the texture. We can also isolate brushes with Control-I. And then we can see each face without entire world, which is distracting. And I select this face. With Alt, I can copy the face and then mirror it. That's okay enough for me. Then with Control-Shift-I, we can go back and see everything in the world. Then I'll reduce the grid size, move it a bit in. It doesn't have to be perfect. So then we make a door out of this by right-clicking, create brush entity func door. And that's the way. This is something I haven't showed you so far, but this is the way you can create brush-based entities instead of just working with only the world spawn entity in the engine. And we can set a few properties for this. And this is a special key. This is something you can look up in the game code. But if you set angle -1, it basically means that the door should move upwards. So in order to get this working, we have to place this portal a little bit inside of the door. Reload. The portal is closed. Okay. So if we use the wireframe mode, the portal is closed. We run, and we can open the portal. Yeah. Not very difficult. And this is typical old school door. Yeah. And this is really nice. And another example is, you probably have seen this, this identified in the HUD. Yeah. And this is, it tells the player the location you're located in. Okay. So we can look for info location. Place one into this room. And give the location key. Something like entrance. This is the entrance room. And then we also want to have here another info location, and we call this storage. Okay. And I don't want to copy the door and everything. This is just a simple example. There are also more entities that can work with the BSP tree and are aware in which area of the BSP they are, like the vacuum stuff, info vacuum. This is something that you can use, or have you seen in the Doom 3 main campaign, when you shoot a glass and you are breaking the window, and then you running out of air because of the Mars environment. Yeah. But this time we just want to tell the player where he's located in the game. And I haven't changed any brushes, so I can just reload the map. And voila, we are located in trance. And now we are located in storage. So this is the way the game code can utilize it, and this pretty much wraps up this video. I hope you enjoyed it. It's already long enough, and see you in the next video.